400 years. That's how long we've been watching Jupiter. Galileo pointed a handmade telescope at it in 1610. Since then, thousands of astronomers, hundreds of missions, billions of dollars in equipment, all aimed at the same planet. The biggest one we have, the most photographed, the most studied gas giant in the history of science. And in 2016, when we finally sent a probe close enough to look it directly in the face, scientists didn't recognize it. The researchers who had spent their careers studying Jupiter looked at the first images from its poles and genuinely could not match what they were seeing to any model, any simulation, any prediction they had ever made. 4 centuries of observation. Every model we built was wrong. Every assumption we staked careers on collapsed. That was the first failure. There were 4 more waiting. We thought we knew what Jupiter looked like. The bands, the swirls, that 400-year-old red storm sitting in the southern hemisphere like a bruise that never heals. We put it on posters. We named its features. We built entire atmospheric models around the patterns we could see from Earth. Then Juno swung into polar orbit, the first spacecraft in history to look at Jupiter from above, and sent back images of the North and South poles. What it found was nothing like the planet we thought we knew. No bands, no order. Instead, dozens of cyclones, massive and tightly packed, locked in geometric formations around both poles, each one between 1,400 and 1,800 kilometers wide. The South Pole has 5 of them arranged in a pentagon. The North Pole has 8, orbiting a central storm in near-perfect symmetry. Each one of those cyclones covers more surface area than the continental United States. Some are wider than the entire Atlantic Ocean. They've been sitting there holding formation for years. That was just the outside. For decades, scientists were split into 2 camps about what sits at the center of Jupiter. Camp 1 said Jupiter formed around a dense rocky core. Ice and stone clumping together first, gravity doing the rest, pulling in hydrogen and helium over millions of years until it became the giant we see today, a pearl built around a grain of sand. Camp 2 said there was never a core at all. Jupiter collapsed directly out of a gas cloud, no solid center, just gas all the way through. Both camps had math. Both had careers staked on the answer. Juno made both of them wrong on the same day. The data came back showing something neither side had ever proposed. A fuzzy core, not solid, not absent, something in between, a region where heavy elements don't form a defined center, but instead dissolve outward, gradually blending into the surrounding gas with no clear boundary. Spanning approximately 130,000 kilometers, nearly half the planet's total radius. When the results came in, researchers immediately reached for the most obvious explanation: a massive collision early in Jupiter's history, shattering a once solid core and mixing the debris into the planet's interior. So they ran the simulations, supercomputers modeling every possible impact, different sizes, different speeds, different angles, hundreds of scenarios. Every single one failed. In every simulation, the heavy material did the same thing. It scattered on impact. Then it slowly sank back down, settled, rebuilt the boundary, every time, without exception. The math kept returning the same answer. A dissolved core is physically impossible, and yet Jupiter has one. Jupiter's magnetic field is the largest single structure in our solar system. It stretches 650 million kilometers behind the planet, past Saturn's orbit. If you could see it from Earth, it would appear twice the size of the full moon in our sky. And for years, we thought we understood it. Fast rotation, liquid metallic hydrogen deep in the interior, simple dynamo process. Juno built the most detailed map of it ever made, and that map immediately invalidated the explanation. The northern hemisphere is 3 to 4 times stronger than the southern. There are 2 magnetic south poles. There are intense localized regions where the field concentrates in ways that have no clean theoretical cause. And then there's the Great Blue Spot, a magnetic scar near Jupiter's equator where the field is unusually dense. Juno watched it across multiple orbits and found something that had never been observed on any planet before. The magnetic field was moving, shifting, drifting westward at roughly 3 centimeters per second, dragged by Jupiter's deep atmospheric winds. Scientists called it secular variation, a first for the solar system. But here's the fatal problem. The fuzzy core, the discovery that was supposed to eventually explain the magnetic field's strange behavior, made it more broken, not less. Modeling the interior with a fuzzy core produces a magnetic field that looks nothing like what Juno is actually measuring. We have better data than we've ever had, and we understand less than we thought we did. Juno was designed to die young, 20 months in orbit, then a controlled plunge into Jupiter's atmosphere. That was the plan. The radiation belt alone, at peak equivalent to 20 million chest X-rays per year, was expected to slowly destroy its instruments from the inside out. Instead, the radiation levels near Jupiter's poles came in 10 times lower than predicted. The spacecraft that wasn't supposed to survive its own mission kept going, into an extended mission that sent it where no probe had gone before, the moons. Ganymede. Scientists expected to confirm oxygen in its thin atmosphere. They found water vapor instead, forcing a revision of atmospheric models for every icy body beyond the frost line. Not just Ganymede, every one of them. Europa, up close. The highest resolution images ever taken, at 256 meters per pixel, of its fractured surface revealed something unexpected. Evidence of brine reservoirs trapped inside the ice shell itself, not just in the ocean far beneath it. Pockets of high salinity liquid expanding under pressure, cracking through ice that's over 10 kilometers thick. And Jupiter's lightning, a mystery sitting unsolved since Voyager passed through in 1979, finally got an answer. The flashes weren't coming from water storms deep in the atmosphere. They were coming from somewhere far too cold, below minus 88 degrees Celsius, for liquid water to exist. Because they weren't water storms. They were ammonia-water hybrid clouds, where ammonia acts as antifreeze, keeping a liquid mixture stable at temperatures that should freeze everything solid. And the hail falling out of these storms isn't ice. Scientists are calling them mush balls. Jupiter is raining slush. Juno was completing a routine flyby of Io, Jupiter's innermost large moon, the most volcanically active world we've ever found. A surface so constantly reshaped by eruptions that impact craters form and disappear within decades. Io ejects 1 ton of material into Jupiter's orbit every single second. On that day, the instruments lit up across the board. Hundreds of volcanoes scattered across a region spanning 65,000 kilometers roughly 5 times the diameter of Earth, erupted simultaneously. Together, the synchronized timing suggests they're linked. One vast network of underground lava channels, pressurizing, releasing, cascading across the Moon's interior in a single coordinated event. Juno was supposed to be dead by now. It survived its first mission, then its extended mission. Then a government shutdown froze the decision on its fate, and NASA went quiet. Weeks passed, months, no announcement. Then, without ceremony, they published new data. And at the bottom of the paper, a single line: Juno will complete its 81st flyby of Jupiter. A probe engineered for 20 months is now in its 5th year of extended operations. We sent it to answer questions about Jupiter. Instead, it became the question. Because here's what 400 years of watching and one probe actually proved. The models were wrong, not partially, structurally. At every layer we looked. The poles don't behave the way physics said they should. The core doesn't exist the way either theory predicted. The magnetic field doesn't work the way our models described. The moons don't look the way we expected. The storms don't fall the way water should fall. That gap has a name. It's called Jupiter. And we still don't know what's inside it. The probe is still transmitting. The data is still coming in. And every new orbit is producing results that don't fit the model. We weren't wrong about a few details. We were wrong about the planet. You think the sun is massive. You could fit 1,300,000 Earths inside it. Jupiter is over 1,300 Earths. That sounds smaller. It is smaller, but here's what they don't tell you. Jupiter tried to become a star. It ate everything in its path. Dust, gas, rock. It kept growing, kept pulling. It wanted to ignite. It wanted to burn. And then at the last moment, just 1% short of fusion, it stopped. So what do you get when a star refuses to wake up? You get a bomb that never went off. You get a planet that isn't really a planet. And if you fell into it, there would be no ground to catch you. You would just fall forever. Every planet has a surface. Mars, red rock and iron dust. You could stand on it. Venus, volcanic plains hot enough to melt lead. Deadly, but solid. Even Saturn. If you could somehow survive the descent through its clouds, you'd eventually hit something. Somewhere deep down, there's a core. Jupiter has no surface. Think about that for a second. No ground, no rock, no place where the falling stops. 99% hydrogen and helium. The exact same recipe as the sun. The exact same ingredients that make stars burn. But Jupiter never lit the match. So when you fall in, at first it looks almost normal. White clouds, ammonia ice crystals, negative 150 degrees Celsius. Cold, but not impossible. You keep falling. The clouds turn brown. Sulfur compounds mixing with the hydrogen, then rust red, phosphorus, then orange, then black. And you're still falling. But now it's not gas anymore. The hydrogen is too compressed, too thick. It turns into liquid. You're not falling through air. You're sinking through an ocean of hydrogen, an ocean with no bottom, no surface above, no light, just pressure, and it keeps building. Deeper still, the pressure gets so extreme that the hydrogen forgets how to be a liquid. It becomes metal, not solid metal, not liquid metal, something in between, a conducting fluid, metallic hydrogen. Electrons ripped free from atoms flowing like electrical current. An ocean of liquid metal generating a magnetic field 20,000 times stronger than Earth's. This ocean is larger than our entire planet. And it's been down there for 4.5 billion years. This is what happens when a star gives up halfway. The Great Red Spot, 1665. That's the year Giovanni Cassini first spotted it. A red oval, a blemish on Jupiter's surface. He didn't know what it was, just something that shouldn't be there. 1830, still there. 1979. Voyager 1 photographs it. 3 Earths wide. Winds screaming at 400 miles per hour. A hurricane that makes every storm on Earth look like a breeze. 2025, still raging. Empires have risen and fallen. Species have gone extinct. We invented electricity, flight, the internet, and that storm just kept spinning. But here's the thing, it's shrinking, losing about 580 miles in diameter every year. Nobody knows why. In 100 years, maybe 200, it might be gone. And we have no idea what happens when a 400-year-old storm finally dies. We've never seen one end. Jupiter kills from millions of miles away. Its magnetic field is the largest structure in the solar system. If you could see it, it would stretch from Earth to Mars. Trapped inside that field are radiation belts, high-energy particles, electrons and protons accelerated to 99% the speed of light, bouncing between Jupiter's magnetic poles. They've been building up for 4 billion years. Earth has radiation belts too. The Van Allen belts, peak radiation there, about 1,000 rads. Jupiter's radiation belts? 20 million rads per orbit. Jupiter delivers a lethal dose in 3 seconds. Now think about Europa, one of Jupiter's moons, covered in ice, possibly has a liquid ocean underneath, could have life. But Jupiter's radiation hits Europa with 540 REMs per day. That's 100,000 chest X-rays every single day for 4 billion years. We're searching for life on Europa, while Jupiter is sterilizing it in real time. Any life that exists there isn't thriving despite the radiation. It's hiding from it, miles under the ice, in the dark, in the only place Jupiter's fury can't reach. The king doesn't protect his kingdom. He poisons it. But here's the thing, it doesn't make sense. We might owe Jupiter our lives. July 1994. A comet called Shoemaker-Levy 9 breaks apart into 21 fragments. Each fragment the size of a mountain. They slam into Jupiter. The explosions are visible from Earth. Fireballs 3,000 miles high. Scars on Jupiter's surface the size of our planet. If those fragments had hit Earth, extinction. No question. Computer models have been running for decades, simulating asteroid trajectories, calculating odds. The math says Jupiter's gravity catches about 1,000 asteroids for every one that reaches the inner solar system. For 4 billion years, it's been pulling danger away from us. A cosmic shield. But the same simulations show something else. Jupiter also throws asteroids inward. Gravitational slingshot, chaotic orbits, the 3-body problem, no perfect solution. The numbers don't add up cleanly. Jupiter blocks roughly 60% of potential impacts. But Jupiter also causes about 10% of actual impacts. Net protection, 50%. So here's the question nobody can answer. The asteroid that killed the dinosaurs, Chicxulub, 66 million years ago. Did Jupiter catch it and miss, or did Jupiter throw it at us? We don't know. The math is too chaotic. The three-body problem has no clean solution. We can simulate, we can estimate, but we can't rewind time. Jupiter might be our guardian. Jupiter might be our assassin. Most likely, it's both. And we'll never know which version saved us, or which version will kill us next. Jupiter is a catalog of almosts. Almost became a star, stopped at 99%. Almost protects us completely, but also threatens us. Almost kills everything that gets close, except its moons somehow survive. In 5 billion years, the Sun will become a red giant. It will swallow Mercury, Venus, probably Earth. Jupiter will still be here, still spinning, still crushing, still generating a magnetic field strong enough to break physics. We live in a solar system of accidents, a star that almost ignited, an asteroid belt that almost became a planet, a Mars that almost kept its atmosphere, an Earth that probably should have been hit 1,000 times by now. Everything here is an almost. Jupiter doesn't care what we call it. Planet, failed star, radiation hell, protector. It just keeps doing what it's always done. Spinning at 28,000 miles per hour, crushing hydrogen into metal, trapping radiation for eons. Not a planet, not a star, just an unfinished thing. That happens to be 1,000 times more massive than everything else we know, combined. In October 2024, NASA's Juno spacecraft transmitted data that changed everything we thought we knew about Jupiter. The core, the massive ball of rock and metal that anchors the largest planet in our solar system. It's not solid. It never was. And right now, it's dissolving into the metallic ocean around it. Juno has 1 year left before Jupiter's radiation kills it. 1 year to answer a question that makes no sense. How does a planet lose its core and still exist? But that's not the disturbing part. The disturbing part is what happens if it finishes collapsing. Every image you've seen of Jupiter is makeup covering something impossible. Those clouds, those storms, the famous red spot. They're window dressing on a planet that shouldn't exist where it is. Jupiter is too big, too hot, too far from where it was born. And somehow, for 4 billion years, it's been standing between Earth and the radiation that would strip our atmosphere into space. But we didn't know any of this until we tried to look inside. And when we finally did, we found something that defies the laws of planetary formation. Here's the problem with Jupiter. You can't land on it. You can't drill into it. You can't even fly a probe deep enough to matter before the pressure crushes it. Mars? We drive robots across the surface. Venus? We've dropped landers into the atmosphere. Saturn? We deliberately crashed Cassini through the rings to collect data on the way down. But Jupiter eats spacecraft. In 2003, NASA sent Galileo into Jupiter's atmosphere to avoid contaminating the moons. The probe was designed to withstand 20 times Earth's atmospheric pressure. It survived 8 minutes, not because it hit anything, because the hydrogen around it got so dense, so compressed, that it stopped being gas and started becoming liquid. The spacecraft didn't crash, it drowned in an ocean made of air. So when Juno arrived in 2016, NASA didn't try to go deep. They went for gravity. By measuring how Jupiter's gravity tugged on Juno as it flew past, down to shifts smaller than a human hair, scientists built the first map of what's actually inside the planet. And the map made no sense. The core was there, but it wasn't solid. It wasn't even in one place. Dr. Scott Bolton, Juno's principal investigator, described it like this. "We expected a clean boundary, liquid on top, solid core below. What we found was more like cosmic soup. The core isn't collapsing. It never fully formed in the first place. Jupiter has a blurry core, a diluted core, like someone put a normal planet in a blender and hit pulse, and nobody knows why." But the gravity data revealed something else. At the center of Jupiter, 30,000 kilometers below those clouds, pressure does something no laboratory on Earth can recreate. It turns hydrogen into liquid metal. Here's how that works. Hydrogen is the simplest element. One proton, one electron. Under normal conditions, those electrons stay bound to their atoms. But at the center of Jupiter, the pressure is so extreme that it rips electrons away and lets them flow freely, like water. That's metallic hydrogen, a liquid that conducts electricity. If you could somehow bottle 1 liter of this stuff and bring it to Earth, it would weigh 700 kilograms. And the instant the pressure dropped, it would explode with the force of a small nuclear weapon. Jupiter has an ocean of it, 30,000 kilometers deep, spinning, churning, generating electric currents on a scale we can barely measure. And those currents create Jupiter's magnetic field, a magnetic field 20,000 times stronger than Earth's. Strong enough to trap radiation from deep space in a bubble that stretches millions of kilometers across the solar system. This bubble is called the magnetosphere. Every orbit Juno makes through Jupiter's radiation belt, the electronics degrade a little more. NASA built the spacecraft with radiation shielding thicker than a bank vault. Jupiter's magnetosphere traps so much radiation that being near the planet is like standing inside a particle accelerator. Then there's the surface, if you can call it that. The Great Red Spot. A storm so large it could swallow Earth whole. A hurricane that's been raging since before the United States existed. It's dying. In the 1800s, astronomers measured the red spot at over 40,000 kilometers wide, big enough to fit 3 Earths inside. Today, it's barely 13,000 kilometers across. In 200 years, it's lost 70% of its size, and nobody knows why. The storm isn't slowing down. The winds inside still reach 400 kilometers per hour, but the spot is shrinking, tightening, compressing into something smaller and more violent. One theory, the jet streams that feed the storm are weakening as Jupiter's internal heat output changes. Another theory, the storm is sinking deeper into the atmosphere and we're only seeing the top. But here's what makes it worse. As the red spot dies, new storms appear. In 2019, Juno watched a storm form in real time. It started as a small white oval. 6 weeks later, it was the size of Texas. Winds inside reached 600 kilometers per hour, and then it merged with another storm and became something we've never seen before. On Earth, hurricanes last days. On Jupiter, they're measured in centuries. And when they die, they don't fade. They get replaced by something bigger. Because Jupiter isn't just covered in storms. It's powered by them. Jupiter is a self-heating engine. It generates its own weather, its own lightning, 1,000 times more powerful than anything on Earth. Its own wind systems that never stop because there's no ground to slow them down. And all of that energy, all of that heat, all of those eternal storms, they're driven by the same core that's dissolving right now. We've sent probes, we've measured gravity, we've mapped magnetic fields, we've watched storms rage for centuries and tracked lightning that could power entire cities. And yet Jupiter remains unknowable, a liquid metal ocean 30,000 kilometers deep, spinning in eternal darkness, a blurry core that never solidified, a magnetic shield we can't survive without, a migrant planet that stopped moving at exactly the right moment for exactly the right reasons, and we have no idea why. Maybe that's the point. Some things in the universe aren't meant to be fully understood. They're meant to remind us how small we are, how fragile, how utterly dependent on forces we can't control and barely comprehend. Jupiter has been protecting Earth since before the first cells divided in our oceans. It will keep protecting us long after our species is gone. And it will do this with a core that makes no sense. Powered by physics we're only beginning to understand, driven by mechanisms we can't replicate. Every time you see that bright dot in the night sky, remember this. You're only here because a planet with a blurry core and a dying storm is standing between you and oblivion, powered by an ocean of liquid metal, wrapped in a magnetic field that's shifting for reasons we can't explain. That's Jupiter, and it's not what you were taught. In February 2026, Juno's 81st orbit confirmed something that shouldn't exist. Jupiter has a core. Jupiter doesn't have a core. Both statements are true at the same time. This isn't a sensor glitch. The measurements have been verified for 9 years. What NASA found below Jupiter's clouds broke every model we had for how planets form. And it gets worse. When Juno measures Jupiter's gravity, it's reading the planet's fingerprint. Every variation in speed tells us what's underneath. Dense material speeds the probe up. Lighter material slows it down. It's physics. It can't be faked. For decades, scientists expected one of two answers. Either Jupiter formed from a gas cloud collapse with no core at all, or it built a solid rocky core first, then captured gas around it. The data matches neither. Instead, Juno found a gradient. Heavy elements mixed through half of Jupiter's radius, with no boundary separating them from the lighter hydrogen above. Scientists call it a fuzzy core. Think of it like this. You expect an egg with a clear yolk and white. What you get instead is a latte, where espresso swirls through milk with no clean separation. The question isn't just what this is, it's how something this unstable survived for 4.5 billion years. The obvious answer? Planetary violence. Maybe Jupiter started normal. Solid core, gas envelope, everything textbook. Then another planet-sized object smashed into it early in solar system history. The impact scrambled everything like two eggs hitting at thousands of kilometers per second. Scientists got excited. This could explain the fuzzy core and Jupiter's lopsided magnetic field. So they tested it. Supercomputers ran hundreds of collision simulations, different impact angles, different speeds, different ages of Jupiter when it got hit. Every single simulation failed the same way. Here's the problem. Heavy elements sink. Always. It's thermodynamics. Even after a catastrophic collision scrambles Jupiter's interior, gravity pulls the heavy stuff back down. The models showed this happening within 100 million years. Jupiter's core should have reformed a clear boundary. But Juno's data shows it's still mixed after 4.5 billion years. That's 45 times longer than the settling time. Something is keeping those elements permanently scrambled against every natural force trying to separate them. What could do that? The answer came from Saturn's rings. Scientists noticed the rings vibrating in specific patterns, responding to oscillations deep inside Saturn. It's like studying Earth's interior through earthquakes, except the sensors are ice particles 400,000 kilometers away. When they combined ringwave data with Cassini's gravity measurements, they found something shocking. Saturn has the exact same fuzzy core structure. Two gas giants, identical internal architecture. The odds of two random collisions creating this? Astronomical. This isn't an accident. It's not collision damage. It's something fundamental about how all gas giants form. The textbooks were wrong from page 1. Gas giants don't build themselves in neat layers. During formation, temperature and pressure create stable zones where heavy elements get trapped. They can't sink. They can't fully mix. They just sit there, creating a permanent gradient that defies our intuition. And here's what that means. We've discovered over 4,000 exoplanets. Many are gas giants. We've been modeling every single one of them incorrectly. Wrong core structure means wrong atmosphere predictions, wrong evolution timelines, wrong habitability estimates for their moons. Jupiter didn't just break our model of Jupiter, it broke our model of planetary formation everywhere. Scientists hoped the fuzzy core would explain Jupiter's other mystery, its impossible magnetic field. Jupiter's magnetosphere is the largest structure in the solar system. It extends 1 billion kilometers past Saturn's orbit. Generated by an ocean of metallic hydrogen spinning inside the planet. But the field is wrong. Earth has 2 magnetic poles, north and south. Jupiter has 3. The North Pole is strong and concentrated. The South has a weak pole plus a second South Pole offset to the side. It's lopsided in a way that shouldn't be stable. When scientists modeled how a fuzzy core would affect the magnetic field, they expected answers. They got more questions. The stable, non-convecting regions that create the fuzzy core should generate completely different magnetic patterns than what Juno measures. Current theory involves helium rain falling through the interior, creating electrical currents that distort the field. But here's the truth. 9 years of data and we still don't fully understand how Jupiter's magnetic field works. The fuzzy core didn't solve the mystery. It made the mystery bigger. If Jupiter formed differently than we thought, that changes how Earth formed. Jupiter's migration through the early solar system distributed heavy elements everywhere. It determined where water condensed. It controlled which materials reached the inner solar system when rocky planets were forming. Understanding Jupiter isn't just about understanding one planet. It's about understanding why Earth has oceans, why Mars lost its atmosphere, why Venus became hell. The Europa Clipper launches in 2030. It will measure Jupiter's gravity from different angles, potentially revealing how deep the fuzzy region extends. Future missions might drop probes into Jupiter's atmosphere, sampling the transition zones directly. But every answer creates 10 new questions. The fuzzy core isn't a weird exception. It's the rule, and we missed it for decades because we never looked carefully enough. Here's the twist nobody expected. Juno was supposed to die in 2018. The mission got extended to 2025. But in February 2026, NASA confirmed Orbit 81 is complete and Juno is still functioning. The radiation belt that was supposed to fry its electronics in 20 months? Juno found a gap in the field during its first approach. It's been threading that needle for 9 years. Nobody knows how long it will last. Eventually, the orbit will decay and Juno will fall into Jupiter's atmosphere. When that happens, it might get closer to the cloud tops than any probe in history. Imagine what it could see in those final moments. Closer to the fuzzy core, deeper into the metallic hydrogen ocean, right into the mechanism generating that impossible magnetic field. NASA hasn't announced when they'll deorbit Juno. Maybe they're waiting to see how long it survives on its own. Because here's what 9 years of impossible data taught us. Jupiter doesn't follow the rules. Not formation rules, not magnetic rules, not survival rules. And Juno? Juno stopped following mission rules the day it arrived. That measurement in 2026 rewrote textbooks. The fuzzy core forced us to rethink 4.5 billion years of planetary evolution. But the real revelation isn't what we found. It's what it cost us. Every model we built for gas giant formation was wrong. Every exoplanet interior we mapped was wrong. Every prediction about how these systems evolve was built on a foundation that doesn't exist. We didn't just discover something new about Jupiter. We discovered that our most fundamental assumptions about how worlds form were fantasies. And Jupiter is still keeping secrets. Somewhere in that fuzzy core, in the swirling gradient between rock and gas, there are mechanisms we haven't even thought to look for. Gravity doesn't lie. But sometimes gravity tells you truths you weren't ready to hear. "60 years. 2 camps, both certain. The smartest planetary scientists on Earth argued about. What sits at the center of Jupiter? Half of the best planetary scientists on Earth said Jupiter had no core, gas all the way down. The other half said it had a solid core, dense, compact, the foundation everyone else was built on. Then NASA sent Juno. It collapsed both answers simultaneously. Jupiter's core exists, but it has no edges, no boundary, no defined center. The largest planet in our solar system, 1,300 Earths in one object. And the physics inside it breaks every model we build to explain how planets like Jupiter are supposed to work. To understand what Juno broke, you need to feel how certain everyone was. The first camp had a clean story. Jupiter formed like a failed star, a massive gas cloud collapsing under gravity. No solid center. If you fell beneath the cloud tops, you would never hit ground. Pressure would climb, temperature would climb, and you would still be falling. The second camp had an equally clean story. Heavy elements condense first in the cold outer solar nebula. Rock, ice, iron. They accumulate. Gravity pulls in hydrogen and helium on top, and you get a giant planet with a solid nucleus at its foundation. Two groups, two airtight frameworks, both built into textbooks taught on every continent. Then Juno's data arrived. And the universe didn't pick a winner. Juno doesn't photograph Jupiter's interior. It listens to how Jupiter pulls it. The spacecraft swings within 4,200 kilometers of the cloud tops, and Jupiter's gravity has a continuous conversation with it. Every variation in mass distribution creates a gravitational tug, changes in velocity as subtle as 0.01 millimeters per second, slower than the hour hand on a clock. Juno detects all of it via Doppler radio signal. Pass after pass, orbit after orbit. A mass map approximately 100 times more precise than any previous Jupiter mission. Both camps had their predictions ready. Both expected to win. There is a core. The mass data makes that clear. But it has no defined edge. The heavy elements at Jupiter's center don't end at a boundary. They thin out, gradually, over a region spanning roughly half of Jupiter's total radius. Approximately 70,000 kilometers from center outward. Earth's entire diameter is 12,700 kilometers. Jupiter's core region is wider than 5.5 Earths stacked side by side, and it has no surface. Nothing you could point to and say, here is where the interior ends. This is a direct violation of what the standard planetary formation model requires. To build a giant like Jupiter, core accretion theory demands a solid, compact nucleus, a clear foundation gravity can build on top of. What Juno found is a gradient, a slow dissolve, a center that does not behave like a center. 3 doors open simultaneously. Either Jupiter formed this way, which breaks core accretion theory, or something catastrophic destroyed the solid core after formation, or our physics at these pressures is fundamentally incomplete. All 3 doors are still open. The collision theory felt tractable. A protoplanet, 10 times Earth's mass, hit a young Jupiter at high velocity. The impact shattered the solid core. Heavy debris scattered upward into the hydrogen layers. And what Juno measures billions of years later is the aftermath, a diffuse, boundaryless remnant. The impact scattered the debris, and then the heavy material sank, like sediment settling to the bottom of a disturbed glass of water. A sharp boundary reformed. Every time, without exception. The answer came from Saturn. Saturn's rings aren't static. They ripple, enormous waves driven by vibrations deep inside the planet. Researchers asked, what if those waves are Saturn communicating something about its own interior? When they combined the ring wave data with Cassini's gravitational measurements, the analysis required one specific conclusion. Large regions of Saturn's deep interior are not convecting. Something is holding heavy elements toward the center, allowing them to thin out gradually without a clean boundary. Saturn has a diffuse interior too, published in 2021, peer-reviewed, independent of the Juno result. Two gas giants, different distances from the Sun, different sizes, different compositions, the same anomalous structure. This is no longer a coincidence. It cannot be explained by a collision. If both Jupiter and Saturn share this characteristic, then it's not an accident and it's not an aftermath. It is likely how gas giants form, which means every planetary formation model built on solid cores and clean compositional boundaries needs to be rebuilt. Look at the full scale of what this overturns. More than 5,000 confirmed exoplanets have been cataloged, classified, and modeled using frameworks built on the assumption of solid cores. Cooling timelines, interior pressure profiles, habitability assessments, all derived from models that are now structurally suspect. And the two planets used to build and validate those models, Jupiter and Saturn, are the only gas giants close enough to study with the precision Juno and Cassini achieved. The thousands of gas giants beyond this solar system have been labeled using a framework that may not describe what is actually inside any of them. One more layer, Jupiter's magnetic field. The magnetosphere extends nearly 1 billion kilometers behind the planet, large enough to contain Saturn's orbit, generated where pressure exceeds 4 million times Earth's atmospheric pressure, where hydrogen loses its electrons entirely and becomes electrically conductive. The result, a magnetic field 20,000 times stronger than Earth's. And it has features that have never been explained. Stronger in the north than the south. Intense localized concentrations at specific latitudes. Two magnetic south poles. A configuration that should not exist if the dynamo were operating uniformly. Scientists hoped the diffuse core would explain these anomalies. They modeled it. The diffuse core does not explain the anomalies. It makes them harder to explain. Unknown mechanism, no consensus, active research, no resolution. At both poles, continuous ultraviolet auroras burn without pause, covering regions larger than Earth's entire surface, releasing more energy per day than all of Earth's auroras in a year. Hubble captures them in ultraviolet. We cannot see them with the naked eye. The field that powers them remains unexplained, beautiful, relentless, unexplained. Here is the precise inventory. We know Jupiter has a diffuse interior spanning roughly half its radius. We know Saturn has the same structure. We know the collision model was computationally tested and failed. We know our planetary formation models require a foundation neither planet appears to have. What we don't know, whether this structure is stable or slowly evolving, whether the formation models need modification or replacement, whether the thousands of exoplanets we've cataloged are structured anything like we believe, whether the magnetic anomalies are a consequence of the interior or a separate problem entirely. Juno was sent to settle a 60-year argument. It settled nothing. It dissolved the question. Jupiter is still out there, interior undefined, boundaries absent, magnetic field operating by unknown rules, auroras burning at both poles without pause. The largest planet we can examine in detail. And its center remains one of the most consequential unsolved problems in planetary science. Jupiter's south magnetic pole is failing, not slowly, not gradually. 20% weaker than it was 5 years ago, and nobody saw it coming. This isn't a measurement error. 3 independent spacecraft confirmed it. Juno's magnetometer recorded the drop during its latest pass. The field lines that should anchor deep into the planet are bending, twisting, collapsing inward like a structure losing its foundation. Here's why that matters. Jupiter's magnetic field is the largest structure in the solar system. It stretches 2 million miles into space, trapping radiation that would sterilize anything organic in hours. Earth's entire magnetosphere could fit inside one of Jupiter's field loops 20 times over, and now it's failing on the southern hemisphere. Scientists just figured out why, and the mechanism behind it suggests Jupiter's interior is nothing like what the textbooks describe. It's worse, and it's irreversible. Jupiter generates its magnetic field the same way Earth does. A spinning core of conductive material creates a dynamo. But Jupiter's core isn't iron, it's metallic hydrogen. Liquid hydrogen compressed under so much pressure, it stops being a gas and starts conducting electricity like metal. Nobody has ever seen metallic hydrogen. We can't make it in a lab. The pressures required are beyond anything we can replicate. It only exists in the crushing depths of gas giants. And Jupiter has an ocean of it, thousands of miles deep, spinning with the planet. But here's the problem. Juno's gravity measurements just revealed the metallic hydrogen layer isn't uniform. The southern hemisphere's layer is thinner, uneven, like the planet is lopsided on the inside. That asymmetry is why the south magnetic pole is collapsing. A thinner metallic hydrogen layer generates a weaker field. And as Jupiter spins, the imbalance is getting worse. The field lines are being twisted by the rotation, knotting themselves into unstable configurations. This isn't a temporary fluctuation. This is structural. While Jupiter's magnetic field collapses below, something impossible is happening above. At the North Pole, 8 cyclones have been locked in perfect geometric formation for over 6 years. Each storm 600 miles across, each one spinning at 400 miles per hour, and none of them drifting even slightly out of position. Gas giants aren't supposed to have stable geometry. Their atmospheres are chaos. Wind speeds vary by latitude. Pressure zones shift. Heat convection creates turbulence. There's no framework for 8 independent hurricanes to maintain spacing like they're welded in place. But they are. And new data suggests why. Deep below the storms in the pressure zones, Juno's microwave scans can penetrate. There are vertical columns of fast-moving gas, convection pillars rising from thousands of miles down, anchoring the surface storms like tent poles driven into bedrock. These pillars shouldn't be stable either, but they are. Because Jupiter's interior rotation isn't uniform. Different layers spin at different speeds, creating shear zones that lock the convection columns in place. It's a planetary scale machine with no off switch. The storms will keep spinning for thousands of years, maybe millions. And there's no atmospheric process that can dismantle them. Jupiter's North Pole is locked into a pattern it can't escape. The Great Red Spot has been shrinking for 200 years. Everyone knows that. But new high-resolution data reveals it's not fading, it's compressing, getting smaller in diameter but extending deeper into the atmosphere. Juno's latest pass measured the storm's depth at over 250 miles, 50 miles deeper than 5 years ago. Wind speeds at the edge just hit 430 miles per hour, faster than ever recorded. The storm is drilling itself into Jupiter. As it shrinks horizontally, it's gaining energy vertically, penetrating pressure zones that should shred any surface weather pattern. But the red spot isn't being destroyed. It's transforming into something more stable, more permanent. If this continues, the red spot won't disappear. It'll root so deep into Jupiter's atmosphere that no surface turbulence can dislodge it. A storm that's already lasted 300 years could become a permanent atmospheric feature, embedded in the planet like a scar. And there's no mechanism to stop it. The red spot isn't dying. It's evolving into something Jupiter can't get rid of. Europa's ice shell is cracking, not slowly, continuously. Webb Telescope detected water vapor plumes erupting from surface fractures last year, which means Europa's subsurface ocean is under pressure. Enough pressure to force water through miles of ice and launch it into space. That ocean is 100 kilometers deep. No sunlight penetrates. No atmospheric oxygen exchange. Just liquid water under crushing pressure, heated by tidal flexing, sitting on a rocky seafloor in total darkness for 4 billion years. If anything is alive in Europa's ocean, it evolved in complete isolation. No evolutionary pressure from surface predators, no seasonal variation, no migration. Just an enclosed, pressurized abyss with no connection to anything else in the universe. We have no reference for what that kind of isolation produces. Earth's deep ocean life still connects to the surface through nutrient cycles and chemical exchange. Europa's ocean doesn't. It's a sealed system. If life exists there, it's operating on biological principles we've never encountered. Europa Clipper will fly through these geysers in 2030 and analyze the chemistry. If it detects organic molecules, we'll know something is happening down there. But we won't know what, or how, or whether it even resembles what we call life. Jupiter's gravity warps space-time within 400,000 miles. Anything that enters that radius experiences time dilation measurable by atomic clocks. 1 second on Io is not 1 second in deep space. Jupiter is bending reality around itself just by existing, but that gravity comes with cost. Io is being destroyed. Europa's ocean is locked in pressure. Ganymede's magnetic field is being twisted by Jupiter's collapsing south pole. Every moon in the Jovian system is being warped, heated, or irradiated by proximity to a planet that operates as a miniature physics laboratory. Jupiter formed first in our solar system. Its gravity determined where every other planet could exist. It shaped the asteroid belt by preventing planetesimals from coalescing. It deflects comets that would otherwise bombard Earth. But Jupiter isn't stable. Its magnetic field is asymmetric. Its interior is deformed. Its moons are being shredded. And all of it is irreversible. There's no corrective mechanism, no equilibrium state. Jupiter is a machine built with flawed parts, and it's been running on borrowed time for 4 billion years. Right now, 3 spacecraft are recording Jupiter's collapse in real time. Juno measures the magnetic field decay every orbit. Webb tracks atmospheric changes no visible light telescope can see. And in 2030, Europa Clipper will sample an ocean sealed off from the universe since the solar system formed. Jupiter isn't the king of planets, it's a warning. A demonstration of what happens when physics operates at scales we can't control and timeframes we can't escape. And it's happening right now, 40 minutes of light speed away.